Hey everyone, welcome back to the channel. Imagine a super smart text assistant that writes essays, answers questions, or drafts code instantly. Sounds amazing, right? But what if I told you that sometimes this super assistant confidently makes stuff up, amplifies unfair prejudices, or forgets important facts? Today, we're diving into LLM limitations and risks. What can go wrong, why it happens, and what we can do about it. By the end, you'll have a clear, beginner-friendly map of the most important pitfalls and practical ways to reduce harm. Stick around. I've got real examples, analogies, and clear mitigation strategies. Let's get into it. First, quick basics. An LLM, or large language model, is a statistical model that predicts text. It learns patterns from massive amounts of text and then generates likely next words. Think of it like an incredibly wide autocomplete. It doesn't understand meaning the way humans do. It learns associations. That matters because some problems come from this very nature. Quick analogy. Imagine a super fast librarian who has skimmed millions of books and guesses answers by matching patterns. Sometimes brilliant, sometimes confidently wrong. High-level mechanics in plain language. LLMs use neurons and attention to learn how words relate. During training, they adjust billions of parameters to minimize prediction errors. During use, they take a prompt, consider context within a limited window, and output tokens one at a time. Important pieces: training data, what they learned from, model size, how many parameters, context window, how much they can remember at once, and objective, usually next token prediction. Understanding these building blocks helps explain many limitations we're about to cover. Before the limitations, a quick positive note. LLMs are powerful. They can draft emails, summarize long documents, help brainstorm, translate languages, and assist with coding. They scale well and can accelerate many workflows. These strengths are why people adopt them rapidly. But strengths and weaknesses are two sides of the same coin. Knowing both helps you use them smarter. One of the most famous limitations is hallucination. That means the model fabricates facts, citations, or events that never happened, and often does so with confidence. Analogy: imagine the librarian guessing an answer by mixing book snippets. Sometimes the guess sounds convincing, but is wrong. Examples: invented quotes, false statistics, or bogus legal citations. Why does this happen? Because LLMs optimize for plausible continuation, not factual accuracy. They don't have an innate truth checker. Next, bias. Models reflect biases present in their training data, stereotypes, cultural slants, or underrepresentation. That can result in unfair or harmful outputs, especially in sensitive domains like hiring, lending, or healthcare. Analogy: if the librarian mostly read books from one perspective, their recommendations will tilt that way. Biases can be subtle, different phrasing, tone, or omission, and they can compound when used in automated systems without human oversight. LLMs have a limited context window. They can only consider so much text at once. Think of it like short-term memory. If you dump a long document, earlier parts may get lost. This causes issues for tasks needing long-term consistency, multi-step reasoning, or remembering user details across a long session. Newer models extend windows, but it's still a hard limit and a design consideration when building applications. Safety limitations include susceptibility to adversarial prompts and jailbreaks. Malicious users can craft inputs that coax a model into revealing secrets, producing harmful instructions, or bypassing safety filters. Analogy: persuading a polite person to ignore rules through clever wording. This is a persistent risk because models learn statistical patterns, and bad actors can find loopholes. Data privacy is another big concern. Models trained on public and private corpora may inadvertently reproduce sensitive data seen during training. Users worry about leaking proprietary information, personal data, or copyrighted content. Some providers log prompts for quality and safety, so always check data usage policies. For companies, that means careful choices about on-premise models, fine-tuning, or redaction strategies. Beyond technical limitations, there are societal risks. Misinformation spread, automated harassment, economic displacement, and eroding trust in written content are real possibilities. For example, ultra-realistic fake articles or automated scam messages can scale harm. Also, widespread automation may change job markets, creating gains and also requiring careful policy responses. These risks call for multidisciplinary approaches, not just engineering fixes. Let's look at a few real-world examples to make these ideas concrete. Example 1. A model generating false medical advice. Hallucination meets harm. Example 2. Biased resume screening that downgrades certain groups. Bias with real consequences. Example 3. Automated content moderation failures when adversarial users evade rules. Each of these shows why relying solely on model outputs without checks can be dangerous. Now, the good news. Many mitigations exist. First, prompt engineering, crafting inputs to guide the model towards safer, more accurate outputs. Simple techniques. Ask for step-by-step reasoning. Request sources. Set role-playing context like, "You are a careful analyst," and use chain-of-thought prompts cautiously. These improve output quality, but don't solve everything. Second, retrieval-augmented generation. Connect the model to a trusted knowledge base so it fetches real documents and cites them. Analogy, the librarian checking the shelf before answering. This reduces hallucinations because the model grounds replies in source material. Implementations include vector search, document indexing, and citation-aware pipelines. Third, human-in-the-loop and moderation. Critical applications should have humans review important outputs. Moderation layers can block harmful content or flag risky responses. Human oversight is crucial in legal, medical, or high-stakes decisions. It balances efficiency with responsibility. Fourth, improve training evaluation. Use diverse, high-quality datasets, fine-tune with domain-specific examples, and run robust bias and safety testing. Automated evaluation metrics are helpful, but pair them with human audits to catch subtle issues. Continuous monitoring after deployment helps catch regressions or emergent problems. Fifth, policy and access controls. Limit model capabilities where necessary. Implement rate limiting, logging, and access restrictions. Clear user agreements and transparent data policies build trust. Governance, both technical and organizational, is essential for responsible use. What about the future? Research is tackling hallucinations with better grounding, improving fairness through counterfactual data augmentation, expanding context windows, and designing models that can abstain or ask clarifying questions. There's also exciting work in explainability and formal verification for some behaviors. But these are active research areas. Progress takes time and careful evaluation. If you're a user or builder, here are practical tips. 1. Treat LLM outputs as helpful drafts, not authoritative facts. 2. Use retrieval and cite sources for factual tasks. 3. Add human review for high-stakes uses. 4. Include logging, monitoring, and a way to roll back. 5. Be transparent with end users about limitations and data usage. Small steps like these drastically reduce risk in real deployments. Quick summary. LLMs are powerful tools, but not perfect. Key limitations include hallucinations, bias, limited memory, and vulnerability to adversarial inputs. Risks range from misinformation to privacy leaks and societal impacts. Mitigations include prompt engineering, retrieval augmentation, human-in-the-loop, robust training, monitoring, and governance. Use these models thoughtfully, with skepticism, safeguards, and ongoing evaluation. If this was helpful, smash that like button, subscribe, and ring the bell for more beginner-friendly AI explainers. Drop a comment. What LLM risk surprised you most? If you build with LLMs, share one mitigation you use. I'll read and respond to interesting replies. Also, check the description for resources and links to papers and tools mentioned in the video. Thanks for watching. Stay curious and cautious.